Hello all, welcome to the video lecture. This is Ramesh Lama. Today we will be discussing about the interesting points. First, let's look about the feature. In computer vision, a feature is a measurable piece of data in your image which is unique to this specific point, and it may be a distinct color in an image or a specific shape such as line, edge, corner, or an image segment. The features provide us rich information on the image content, and they correspond to local regions in image and are fundamental in many applications in image analysis such as recognition, matching, and reconstruction. So here first we'll look about the feature matching. In feature matching, the whole idea is to find reliably detectable and discriminable location in two different images. And if I have some points in a scene and I have to figure out which points are same point in the another image of a scene, so the way we are going to do about finding corresponding points using something that we call local features. Here what we do is we have two different images and we try to find out the features and do the corresponding matching between those features. So our goal of feature matching is to find points in an image that can be found in another image, and it's just not found in another image but also find precisely, which means I should be able to precisely determine where that point is. Here we can see here, like if I find this feature in this image, then I should be precisely find it is located at this point. And another one is I should be I should find it reliably. That means it is well matched, and that I want to be really sure that it exactly it is exactly the specified one. That means like if I find this feature here, that I must be sure that this must be the exact one, and it must correspond to this point, not the other point. So I must be sure, and I must be more precise, and then it should be more reliable or well matched. It should be perfectly matched. And the question arises, why do we want to do this feature matching? And the reason is, like, when we want to compute fundamental matrix to recover the geometry, we need the local features, and it's more used in robotics or vision. So we see how a bunch of points move from one frame to another frame, and it allows us to compute computation of how camera moved to estimate the depth and moving objects. And another example is the construction of panorama. So let's see how another motivation is like the panorama stitching, and let's see how the panorama is constructed or built. When we take about the about building panorama, what do we have to do? Like we are going to have a sort of align our pictures in order to be able to place them all together. We have got two images, and I have to align this on this image, like the second image on the first image or first image on the second image. So the first thing we do is we are going to detect some features here. Like first step one, we have to detect the features or feature points in both images. And features, as we have discussed, as I have said before, it's the image patterns which differ from immediate neighbors such as line, edge, or corners. And we are going to define something called the interesting point operator, that I will find some points that I define to be interesting. Here we have selected a bunch of points in both images. Here we have in both images, and these are gonna be our feature points. These are, like, we have selected these points, and this will be the feature points. And the next thing we do is we need to find the corresponding pairs here, like we have to find the corresponding pairs or match the feature pairs. Then that tells us how we need to transform for an image to next and use these pairs to align images. And if we do them, this particular example, we get something that looks like this. Like we can see here, we will get the pair and use these pairs to align images, and finally we'll get the stitched image or the panorama image. So to do this detection, matching and alignment, there are a couple of things that we have to worry about. And the first problem is to detect like if I don't find them in both images, like I can the first problem is like I can possibly match the points. Like I have these points, the red the green circles, and if I find like if this corresponds to these points, then we cannot possibly match these points. So I'm going to take the interest points here and interest point there. These are two like interest point here, the green circles, and interesting points in the red circle, and look for a match. And so it would better be case that the points that's been found have also found over there, and in this particular case there is no chance to match. Like what I'm saying is these 2 points cannot be matched with these points. So what we need is we need a repeatable detector. The repeatable means because I found the same set of 4 points in the left and the different set of 4 points on the right. So what I need is referred to as a repeatable detector. And if I run this image, most of the paths I found were here and being interesting point, and I will also found out here. And so that's the first problem, like reliably finding them. What I mean, what repeatable means that this feature point should be repeated in this image, and this feature point in the first image should be repeated on the second image. So this gives us the perfect matching between the two images. And the second problem is let's assume that these points on the left are somewhere in the right, and so I found 4 points same as in the first images. So for each point each point should correctly recognize the corresponding one. So we need a reliable for this we need a reliable and distinctive descriptor. So what I found is 4 points on the 4 points on the left, then there is 4 points on the right. Which point is which? I have to do the match. So the way we do that is what is referred to as a descriptor, or using the descriptor. Descriptor means it's a description of a point as a feature. To be more precise, what I want one distinctive descriptor. So the descriptor can't change that much of the same point in 2 images. So what I need is I need a more reliable descriptor that describes these interesting points, so that the descriptor of this interesting point, this point and this point are completely different, and it can precisely correspond to this point, or the descriptor of these points should be same, or they should match with each other. So we need some so what makes the good features? So here we have a bunch of features, and as we have discussed before, the repeatability or precision is the most important characteristics of a good feature. That is, the same feature should be found in several images despite the geometric and the photometric transformation. That means the feature that I have found in this picture on the left should also be found on the right one, and that's we call the repeatability. And saliency, that means saliency or matchability, we have just discussed before about the distinctive description. Each feature has a distinctive description, so for the good feature it should have a good distinctive description. Another one is the compactness and the efficiency. Like many fewer features than the image pixels, we should have a very less features than the then the more features, or it should be fewer, like many fewer features than the image pixels. And locality means the descriptor I computed about the feature is based on the relatively small area of the image, and that will give us the more robust features. And another one is the application of interesting points. Like we can see, it can be used in image alignment, it can be used in 3D reconstructions, motion tracking, for robot navigation, and indexing and database retrieval, and object recognition.